naming ionic compounds. We are going to do parts 1 and 2 that I gave you in class. I also gave you guys a periodic table with the ionic charges on it to help you with that, but really any periodic table will do just fine for you. I'll just be using this pretty generic one right here. And let's get started. Naming ionic compounds part 1 gives you the name, and you'd have to come up with the formula. So we'll just be comparing charges here. So let's see. We look at our periodic table, sodium chloride. We see that sodium is in the first column here. So it has a charge of +1, forms a cation, +1. Chlorine is in the 7th column here, so counting backwards, 0, -1. It forms an anion of -1. So sodium +1, chlorine -1. Sodium +1, chlorine -1. Everything looks good, so that's just going to be sodium chloride. All right. Cobalt 3 oxide. Now cobalt is in this block right here. That means it's one of our transition metals. It can have, like many of the transition metals, it can have multiple oxidation states or multiple charges for their ions. But oxide, being here, -1, -2, will always have a -2 charge. So we can pretty much count on that. Not always, of course, but most of the time. Pretty much count on it having a -2 charge. So we've got cobalt, CO. This tells us that the charge is 3+. Oxide has oxygen has a 2- charge. So just cross the charges. So we should have CO2O3. CO2O3. Similarly, chromium 3 chloride. Chloride has a -1 charge. Chromium, it tells us here, has a 3+ charge. Chlorine has a - charge. So we can just say CrCl3. Okie dokie. Lithium iodide. Well, lithium is here, has a +1 charge. Iodide is there, has a -1 charge. Looks like that's just going to be LiI. Lead 2 nitrate. Well, it tells us lead it can also have multiple charges. And it tells us here that the charge is 2. Nitride here, let's see, nitride would have a -1, -2, -3 charge. So lead 2 nitrate, that's Pb, the 2 charge, and nitride there with a 3- charge. So it looks like going to crisscross those, Pb3, N2, Pb3, N2. There you go. Easy peasy lemon squeezy. Silver bromide. Now, you'll note that silver is among the transition metals, but 99.9% of the time, it just forms a +1 cation. So that's how we'll pretty much deal with it, +1. Bromide is -1. So this is just, I've been pointing at gold. I meant to point at silver. So AgBr. Titanium 3 bromide. Well, we know that titanium tells us has a charge of 3. Bromide, we know, has a charge of -1. So cross those charges, that should be TiBr3. Copper 1 phosphide. All right, copper. We know that copper, Cu, has a charge of +1. What's phosphide got here? Well, there's phosphorus right there, so -1, -3. So phosphorus, let's move up a bit here. Phosphorus has a -3. So looks like we will have Cu3B. Tin 4 selenide. Well, let's start with selenium here. That has a charge of -2. Tin, it tells us, has a charge of 4. So SN 4 plus, Se2 minus. Cross the charges. Looks like we're going to have SN2 Se4. All right, zinc sulfide. Although zinc is a transition metal, all these here in the 2B section, Zn, or zinc, cadmium, mercury, they only form a +2 cation. So zinc is 2+, sulfide is 2-. You can see right here, -1, a -2. Sulfur, 2-. So that's just going to be ZnS. Beryllium chloride. Beryllium in the second column there has a +2 cation, and chloride has a -1 anion. So that's just going to be Be2 plus Cl-. Looks like that's just going to be BeCl2. BeCl2. Silver oxide. As we know, silver forms a +1 cation. So silver plus oxygen always forms a minus. Okay. Oxygen forms a 2- anion. So this is going to be Ag2O. Potassium sulfide. Potassium is K. Forms a +1 cation, first column. So K plus. Sulfide, as we now know, forms a -2. So sulfur, 2-. Crisscross, K2S. Hydrogen sulfide. Hydrogen, always +1. Sulfide, 2-. So that looks like H2S. Calcium phosphide. Calcium is here. It forms a +2 cation. So calcium, +2. Phosphide is here. -1, -2, -3. Phosphide forms a -3. Crisscross those, so that will be Ca3B2. Cobalt 3 iodide. Cobalt 3 iodide. Iodide forms a -1 anion. We know that cobalt has a 3+ charge because it tells us right there. So crisscross looks like COI3. Iron 3 phosphide. Well, phosphide, as we just learned, has a charge of 3-. Iron 3, given the name, has a charge of 3+. So that's just going to be FeP. Iron 3 arsenide. All right, well, there's arsenide. Well, there's arsenide right there. It's in the same column as phosphorus, so we can pretty much... Oh, wait a minute, but this is iron 2. Hold the phone. Don't get too excited here. Arsenide has a charge of -3. Iron, in this case, has a charge of 2. So, crisscross those. We will have Fe3AS2. Molybdenum 5 sulfide. Molybdenum is one of our transition metals, but it tells us it has a charge of 5. So molybdenum 5+. Sulfur, as you now know, has a charge of 2-. So crisscross those, we will have molybdenum 2 sulfide 5, MO2S5. And finally, chromium 3 fluoride. Chromium, we know that has a charge of 3, Cr3 plus. Fluoride has a charge of -1. And there it is right there. So crisscross those, looks like we're gonna have CrF3. So there you go. Naming simple ionic compounds right there. All right. Now let's go the other way. This time we're given the name, or the formula. We have to come up with the name. All right. Should be easy peasy lemon squeezy. Let's try here. We know Na is sodium, Br is bromide. So it's always going to be the name of the cation in this case, sodium, followed by the name of the anion, in this case, bromide. All right, K3N, we know that K is potassium, so did I just misspell potassium? Does it have 1 T and 2 S's? Yeah, I think it does. Okay, so make sure you guys spell it right. N is nitrogen, so that's nitride. And I'm just writing these with capital letters by default. You of course, do not have to capitalize chemical formulas, chemical names. All right, VS2, V is vanadium. And however, vanadium is in our transition metal, so we've got to be careful here that we specify what charge that's going to have. So how do we determine that charge? We know that charge based on the anion. Sulfur, you recall, has a charge of -2, and I have 2 of them. So the total charge for my S2s will be -4. So this will be vanadium 4. I signify its charge with Roman numerals in parentheses. Sulfide. Vanadium 4 sulfide. All right, nickel and bromide. Now again, nickel is one of our transition metals here, so I have to be careful about what charge I assign it. How do we know the charge? Well, we get it from the anion, in this case bromide. Bromide always has a charge of -1, which means that if I have 3 of them, the total charge for my bromide will be -3. And that means I'm going to have a nickel 3. Bromide. All right. PBS. Looks like lead sulfide, but lead has multiple charges. Gotta be careful. Now sulfur, as we know, has a -2 charge, which means lead here must have a +2 charge. So we will say lead 2 sulfide. Okay, gallium chloride. Okay, gallium. Gallium sitting right there. Does not have multiple charges, so we don't have to specify a Roman numeral. And chlorine has a 3, but again, we don't need to specify. So that's just going to be gallium chloride. All right. Looks like cobalt bromide. Cobalt is one of our transition metals right there. So here we got to be careful. But we know that bromide always has a charge of -1. That means the charge for 2 of them is going to be a total of -2. That means cobalt must have a charge of +2. So cobalt 2 bromide. All right, Ki. Doesn't get more simple than that. That's just potassium and iodine. So potassium, Potassium. That's much better. Iodide, potassium iodide. Similarly, that's NaF is just sodium and fluorine. So sodium, fluoride, AuAs. All right, let's see here. Au, that's gold. Now, gold is a transition metal, and it can have multiple states, so we've got to be careful here. But arsenic here just has a charge of -3. So arsenic has a charge of -3. Gold must then be +3. So we will say gold 3 arsenide. Okay, Mg. Nothing, you don't have to worry about transitioning with magnesium. Just has a +2 charge. Se has a -2 charge. Magnesium. Selenide. All right, titanium is a transition metal. Can have multiple charges, so how do we determine the charge? We go by the anion. Bromine has a charge of -1. That means Br3 will have a total charge of 3-. That means titanium must have a charge of 3+. So I will say titanium 3 bromide. All right. CuP, that's copper and phosphorus. Copper is a transition metal. Got to be careful here, but phosphorus, well, there it is right there under nitrogen, has a -3 charge. So that means this is a -3 charge, and I have 3 coppers. So be careful here. -3 charge. Each copper, I have 3 of them. That means each copper must be only a +1. Let's see. So I've got copper and I've got phosphorus. I know the phosphorus has a 3- charge. So that means the coppers have to have a 3+ charge, and I have 3 of them, right? So that means I have 3 of those, each with a +1 charge. So I will say copper. Oops, I will copper 1. Phosphide, copper 1, that's a 1. I know it looks like a 2, it's a 1. Copper 1 phosphide. All right, tin and selenium. Well, tin can have multiple charges. We gotta be careful here. So we'll go by the selenium. Selenium right there has a -2 charge. So Se2. What I'm trying to say here, Se2, there we go, Se2. And I have 2 of them, each with a -2 charge, so this has a total charge of 4-, so this will be tin 4 selenide. And you know what? That just reminded me, I made a mistake here on the previous one. We must be careful here. Let's revisit tin 4 selenide right there. You'll note I put SN2SE4. Rookie mistake. If I have a formula where all of the subscripts can be divided by the same number, I should do that. These can all be reduced by a factor of 2. So I should have written SNSE2. Yes, be careful there. SNSE2. All right. Silver bromide. Now, silver is a transition metal, but it almost always forms a +1 cation, so we will treat it as such. So this is just going to be silver bromide, +1, -1. Zinc sulfide. Zinc, where's our good friend zinc? Zinc is right there. Now it is among the transition metals here, but all these in the 2B column just form a +2 cation. So zinc is +2, sulfur is -2. So this is just zinc sulfide. This is just potassium. It's a potassium, forms +1, and sulfur forms a -2, but we don't need to worry about any transitions. It's going to be potassium sulfide. And what we got here? We got calcium, we got phosphorus. Well, calcium, nothing special about it. Phosphorus, so it's just going to be calcium phosphide. All right, FeO, iron. That can be tricky because iron can have multiple charges, usually 2 or 3. So let's see. We know that oxygen always has a charge of -2. That means this one iron must have a charge of +2. So I will say iron 2 oxide. And this says Fe2O3. So again, oxygen always has a charge of -2. That means my O3s in total will have a charge of -6. And iron, I have 2 of them. And to balance out the -6, I must have a +6. And since I have 2 of them, each one must be +3. So iron 3 oxide. So there you go. Naming simple ionic compounds. Thank you very much. We'll go out on the periodic table.